everyone, today we're going to be talking about chemical reactions. So what are chemical reactions? Chemical reactions is like a process that atoms of one or more substances are rearranged to form different substances. Now, what are we going to cover next is whether there are evidences to if a chemical reaction has occurred or not. And the answer to that is yes, there are evidences, and there are 5 main evidences, which are color change, precipitate formation, gas formation, odor change, and temperature change. Now, in color change, the color of the substance changes. In precipitate forms at the bottom. In gas formation, the substance begins to bubble. In odor change, it rots and just the smell of it is hideous. And in temperature change, it either goes really up or really down. So we're going to get to the first one, which is color change. In color change, two substances, as we can see here, two substances are mixed together, and the result in color change evidences that a chemical reaction has occurred. So here we have copper sulfate and iron, and it makes this equation: iron and copper sulfate. Now, when we see the product of it, it's going to be different. It's going to be Cu plus FeSO4. And that makes a different solution. Here it's iron and this is blue. Here, this is copper and this is green. So that indicates that a chemical reaction has occurred. In the next one, this evidence is the formation of precipitate. And here, there are two dissolved substances. So this is something that we could dissolve in, as well as this and this. So there are substance, which is this one, which is a solution, and then a suspension. And these two reacting together make a subordinate, which is a solid product, and then a precipitate forms at the bottom of that. And that is another evidence that a chemical reaction has occurred. The next evidence is gas formation. Now, in gas formation, two solutions, so this is solution 1 and this is solution 2, when they are combined and their product bubbles, we know that a chemical reaction is occurring because this is an obvious evidence. The next one is an odor change. Now, this one happens in every household where your mom buys a basket of bananas, strawberries, blueberries, etc., etc. And you put your strawberries and blueberries in the fridge for 2 weeks, and you forget you have them. And then 1 week, you were like, I want to go eat some strawberries. And then you find out that this has happened to the strawberries. This is all mold, strawberry mold. It's like white stuff that began to form around the strawberry. And then, this is a rotten strawberry. You shouldn't eat it. For instance, your mom buys a carton of eggs. Here are your eggs. And then she gets sick and she doesn't cook and she doesn't use them. And then when she's all good, she's like, okay, I'm going to make eggs for breakfast. And she opens the fridge and she finds that these eggs have turned like this when she opens it. This shows that it's rotten. This is like the egg inside, and then this is the shell. It just shows that the egg is rotten. The red veins in an egg is blue now, and then it's all yellow and it's not white on the inside. The next and last type of evidence to a chemical reaction is temperature. There are two types of temperature. There's exothermic and there's endothermic. In the exothermic, you can feel it, like in a fireplace. In a fireplace, here are your logs. Sometimes it's fake, but you can still feel the heat. But let's imagine that this is an actual fireplace. And then here's the fire, and now I'm redrawing it, but it's okay. And then the fireplace is closed, and then this is like that. And then you're sitting over here with your parents. You're sitting, and this is your mom and dad, for instance, and you can just feel all the heat, and you're warm, so you get extra warm and you go out in the cold. And the other type is endothermic. Endothermic, you won't really tell because this is in chemical substances. For example, you're in school and you have a science experiment and you make this experiment, for example. Let's call this NO, for example. This is NO. And you want to know whether this is a chemical reaction or not. So you take a thermometer, you place it in there, and you get to know whether it's really hot or really cold. And then the next topic we're going to talk about is the types of chemical reactions. There are 5 types. First type is synthesis reaction. So here, 2 or more reactants combine to make a new product. So in this one, for example, carbon, solid carbon, plus O2 gas, of course, makes CO2 gas. This is a type of synthesis reaction. Second one is decomposition reaction. Here, a single reactant breaks down to form 2 or more products. So here, for example, H2CO3, which is an aqueous, makes this breaks down. So it's going to be H2O liquid, because this is water, plus CO2 gas. So this is a gas. So here, a single reactant broke down and it created 2 products, but it could create more depending on the reactant. And the next one is the single replacement reaction. Here, a single element replaces a similar element. It's supposed to be similar. Replaces a similar element in an adjacent reactant compound. So here, zinc, solid, plus CuSO4. Let's just remove this. CuSO4, which is aqueous, makes zinc SO4 aqueous plus Cu, which is solid. So here, this was replaced, and this went here, so this was alone. So this one went here, and then copper was left alone. In a double replacement reaction, 2 ionic compounds exchange ions, producing 2 new ionic compounds. So in this one, an example is NaCl, which is aqueous, AgNO3, which is also aqueous, makes NaNO3 plus AgCl. So we just exchanged them. So we exchanged the Ag and the Na. Here, Na is with the NO3 and the Ag is with the Cl. The last one is combustion reactions. In combustion reactions, a single element or compound combines with oxygen gas, releasing energy, and this is called burning, like we can see in the match over here. So here, C, which is a solid, plus O2, which is a gas, combines with oxygen, makes gas releasing energy, which is CO2. And this is what we breathe. So that is all I had to cover for today in my presentation. I hope you all enjoyed this chemistry presentation. I hope you all understood, and thank you for listening.